Hello everybody. In this video I wanna explain the transient stability studies in the Cape. Uh, After doing the relay settings and define the protection zones for the distance relay, we should define the trip logic for the relay. In the one line diagram tab, by double clicking on the breaker icon, this window will pops up by opening the LZP and going to the protection device and find the relay. Uh, we open it. So we should open the LZOP and going to trip logic tab here. So you can see that there isn't any logic for the relay, so we should define it how the relay detects and detects the fault and operates. So by clicking the manual assigned tab, this will pops up. So in this window, first on the right side you can see that it will be show the different elements of the relay here, the distance elements, and different timers for the elements of the relay. So you can add overcurrent, directional, or auxiliary elements for that, but right now I wanna just work with the distance elements and the timer settings for just zone 1 and zone 2. So right here we should define a trip logic. So first we should click on build and edit an expression, and we should add a logic name here. I wanna name it trip logic for line 2 4, and oh okay, so it said that right now we have something like this. And add the expression here. I wanna put one logic for zone 1 and one for zone 2. So for example I name it Z1 or Z2 T, because I wanna define this one for the distance element for zone 1 and this one for the timer of the zone 2, because in the distance relay typically the settings for the relays, zone 1 is it will be operate instantaneously, so the time we don't have any timer for the zone 1, but we have the delay for zone 2. Typically it's around larger than 5 cycles. So right now you see that we have Z1 and Z2, so we can drag and drop these expressions to the specific elements we want. We know that the distance M1P is related to the zone 1, so we can drag and drop this one, so you see that it will become blue and show that this logic is related to this element. And we wanna put the second one for the timer for the zone 2, so we should find the timer element. It's Z2PD, this one. So you can drag and drop the element here. So by saving these changes, you can see that we have this triple logic here, and close this window. So right now I just want to check that do we have any time delay for zoom 2. We should find this Z2PD element, so you can search it here, and it said that right now it defined as the time delay is as 6 cycles. You can change it to whatever you want, for example 10 cycles, and clicking OK. Okay, so now we set the timer, we set the trip logic for this relay. So I want to check that how it works for that specific relay. So we go to the coordination graphics and open the LZOP zooms and the specific relay, and add the distance elements. We set that. So initialize the display. You can see that the Z1 logic will show here, and you can drag and drop the elements to the zoom. So, and you can add the blinders also. The relay settings will be shown on the right side window. So I want to apply a fault and check that does this relay works and the trip logic works or not. So by right click on the line, you can see that there is a fault here. I want to apply a fault on the midline, so, and apply a 3-phase fault. So right now it said that on the right side window it said that the fault 3-phase is applied on the line, mid of the line between bus 4 and 2, and the summary of the relay settings will pops here, and it shows that after one cycle the zoom 1 will detect that, but the zoom 2 will work after 11 seconds. So we can define the trip logic for this relay too. Going to it takes some seconds to define these protection zones. So go to view LZOP tab, trip logic. Right now we don't have anything, so we should define it manually. You can, if you define the trip logic before, you can select it here, or you can use some default trip logics here, but right now I want to define the new one. So you can open the build and edit expression. So we should name it trip logic line 2 3, and Z, I wanna call it zone 1. You can put and or not, whatever logic you wanna put here, and define your specific logic with different elements. And zone 2 time delay. You can put a expression for blinders, inner and outer blinders, and out of step tripping, out of step blocking here. So it is similar to the previous one. Drag and drop and select the M1P for zoom 1 and timer Z2PD. And the summary of the defined trip logic will be shown here. And close here. So I think we didn't define any time delay here. We have 5 cycles for zone 2 of this relay. So right now we defined the trip logic for the distance relays. Then it's ready to apply the fault and study the transient stability. So we should go to the Cape TS link tab, Cape transient stability link. So, and you can see different toolbar here. First we should start from the specify files for simulation. So the Cape TS links requires different input files from PSSC that we prepared in the previous video. So it needs the load flow file, dynamic snapshot file, bus mapping, and branch mapping files. So we browse the load flow file. We should choose the converted SAV file, which is prepared for the transient stability in the PSSC, and dynamic snapshot with the SNP extension, bus map file, and branch map file. You can select internal or external first, so it depends on the Cape database you choose for the protection platform. If you choose the internal for the protection platform, you should choose internal or external. And you can choose the applying the angle shift for the transformers or not. Then you should choose the fault type, location, and the contingency timing. I want to apply a fault on the branch between bus. Let me show you. I want to apply a fault on this line and check that if this relay detects the fault and how the angles of these generators will be changed. So I wanna apply fault on a branch, go to bus substation 1, bus 2, and a line between bus 2 and 4, and I want to apply a fault on the zone 2 of this relay. So I want to apply a fault on the 90% of the line. The total simulation time is 5 seconds. The contingency will apply at 0.5 seconds. You can choose the fault duration time or put -1 as the instantaneous fault, and this it's a permanent fault for -1. Then you should define the output channels. So the result of the simulation will be saved on different variables and different channels. You can see that there is a small window on the left side of the program as the results read. Right now there isn't any variables here, so you should go to the macro and set tab and choose the define set. So there is a radio tab here. I wanna choose a bus tab. It shows that we should define a set for all buses. And define a set for device, so we can choose the output channel for the relay. I wanna define a new set. We call it display relay 2 to 4 and add the elements to this one. Select the substation and the specific line, and you can see different elements of this relay. So the relay are to line 2-4, and I want to choose zone 1 and zone 2 for this relay. You can see that it shows that 2 elements. Right now we have 2 elements. Click OK. So now you can see that we have 2 devices on this set, and click done. By going to the preference and report tab, you can choose what are your output channels. So we wanna define the all buses, VA and VP, voltage for phase A, and the positive sequence voltage for all buses, and the branches. You can define IA, BC, or I positive for all branches, and the machines. So I have 2 different machines, so I want to save the rotor angle of these machines, and I define the device set. So right now I choose the display relay 2 to 4, and I wanna choose the apparent impedance for this relay. Click OK. Then on the next step you should initialize the Cape TS simulation. On this report window you can see the fault type and the fault location and the contingency timing. the total simulation time as I input as 5 seconds, and it is the permanent fault. So then I want to initialize the simulation. Right now you can see that this transient stability initialized and all the input file bus mapping and branch mapping read by the software, and the positive and zero sequence data and the fault resistance is calculated here. It's a zero resistance and zero impedance fault, and it said that the initialization completed. You can see that we have different output channels here. For example, for the substation 1 we have bus 1 and bus 2. For example, for bus 1 we have different variables. For example, machine 1, I wanna see the rotor angle for generator 1, and we have one relay as an output channel, relay 2 to 4, and I choose zone 1 and zone 2 for this one. Then I will go to apply the fault, and it will go step by step, or you can choose that advanced simulation to the disturbance instance or the breaker operation. So I want to start one step. The delta t of this simulation is this much as the defined time for the cape. You can change it by going to the cape database, but right now I want to use this one. And going one step, you can see that it will show the rotor angle of the generator. Right now it's close to 14 degree, and the protection zones is this is the line and zone 1 and zone 2 of this relay, but the apparent impedance is out of this one. By advancing the simulation time, we can reach to the fault instant. So to do it faster, I choose advanced simulation to the disturbance. So it will automatically do the simulation. So I put the fault at 0.5 seconds. So right now it reached to that time. By going one further step, right now you can see that the fault applied here and show on the one line diagram. So right now it will be report the condition of that. It shows that the three-phase fault applied, and this is a fault location as the here. So since the fault is on the zone 2 of this one, you can see that the apparent impedance enters the zone 2 of this relay. So after the predefined time setting of this zone, as I choose 10 cycles, so this relay should detect and operate. So this breaker will be open. 10 cycle is around 0.2 seconds, so we should go to around 0.7 seconds that this breaker will be open. So you can see that the angle increases. So right now it means that the trip logic didn't work here. So right now it seems that I made some mistakes and it cannot detect this fault. So I will check again the trip logic. So going to the trip logic and check them. So it means that I forgot to put the zoom to timer expression C2PD, so I should drag and drop this one, and right now I think that it will be worked correctly. Initialize this fault and going to the 0.5 seconds to apply the disturbance. So right now I applied the fault and the apparent impedance enters the protection zone. You can choose the advanced simulation to the breaker operation, so it goes here to the time that the breaker opens. So right now you see that the apparent impedance is moved out of the protection zone, so you can see here that the apparent impedance before the fault was here, so it moves to the protection zone, moves into the zone one and zone 2, then it goes, after the breaker opened, it goes out of the protection zone. and the angle starts to accelerate, but the breaker opens. So the summary of the operation of the relay was written here. So you can see that the LZOP of this relay here, and the type is line, and the trip element was Z2P. It means that the after the time delay of zone 2, this relay operates. The time settings for LZOP is 0.7. So it means that after 10 cycles it detects the fault and operates. There is a 2 cycle time delay for breaker, so the total operation time is 0.733. So it means that for the tune zone, for the zone 2 with 10 cycle time delay, this breaker operates and open this line from the bus 2. We can continue this simulation and see what happened to the angle. You can see that the angle is stable and returns. It increases till to 55 degree and return back. You can advance the simulation to your desired time. I wanna put 2 seconds here. And advance the simulation to the final time. You can interrupt this simulation by clicking on this eye icon here and stop the simulation if you forget something and or you wanna check the results. So you can work on this figure and by right click on that, and you can choose different formats or different colors, different fonts for this figure. Also, we have different output channel, for example bus to voltage. This is the phase A voltage and the angles. You can see that during the fault the voltage drops and close to 0 for bus 2, and after it the breaker opens the line from the bus, it goes close to the pre-fault values 1 per unit, and the angle is oscillating. I wanna apply a fault on the zone 1 of this relay, so I should change the fault location to the mid of this line. So I put 0.5s and the same timing for the fault. I will initialize this simulation and advance to disturbance time. You can see that the voltage is constant as 1 per unit for 100 kV, and the angle of the bus 2 is minus 5 degree. So I wanna apply fault and advance it to the breaker operation time. The zone 1 is instantaneous, so there isn't any time delay, so the apparent impedance enters the zone 1, and after the clearing time, so it goes to out of the protection zone. The voltage drops to 0 and then it goes back. You can see that the different timing and the breaker delay and the protection zones delay. So we have totally 2 cycles delay for the zone 1 is for breaker delays as the default value for the cape, but you can change this value in the cape library. And I wanna advance the simulation to 1 second. The total simulation time is 5 cycles. You can see that it's the voltage at bus 2 is convex to the 1 per unit, but its angles is oscillating. This is the rotor angle for generator 1. You can apply a fault on different lines and see what happens. You can to the system variables, voltage, currents, impedance. Also you can define the trip logic for this breaker and set this one as that it can see the fault as the same for this breaker, and it opens and trip this line from the system. There are different tabs here. We work with coordination, graphics, cape TS link, one line diagram, and there is another one, relay setting. that it will set the relay automatically. So for example, by clicking on set relay, and I wanna set the relay on the line 223, so I choose the relay and click OK. So it shows that which element we wanna set. I wanna set the distance element for this relay, so it will get some input from the users as the load angles and load currents and uh, the system operation point. So I wanna work with this value, so you can see that it will set the relay automatically. So it's said that the new settings are ready for the coordination graphics and RC and SS tab, so relay checking and system simulator, but it have not been saved. So before closing this tab, you should save this modified setting, and right now it said that the setting have been saved. So you can change these settings by going to the coordination graphics and finding that specific relay, going to LZOP time, and by initializing, so you can see that it set the relay automatically by the default 80% value of zone 1 for zone 1 and 120% for zone 2. Right now we study the transient stability by linking the CAPE software and PSSE. We should provide different input file for KPTS, such as load flow file, a snapshot file, and bus and branch mapping file. So then we should define the fault type and fault location and the contingency applying fault. Then set the output channel by going to preference and report and choose different devices and the branches, or positive voltage or phase voltages of buses, and rotor angle for machines. Then initialize the simulation and study and see what happened for the system variables. Thank you for watching the CAPE teaching videos. So by these videos you can set the relays and then study the transient stability studies.